Versatile Ralstonia insidiosa C1, a cold-adapted bacterium with dual capabilities in polyhydroxyalkanoate degradation and synthesis. By Young Cheol Chung. Over the past 3 decades, the uncontrolled use of plastics in various sectors, including packaging, transportation, industry, and agriculture, has resulted in a significant challenge of plastic waste disposal. There is a growing interest in replacing traditional plastics with bioplastics to improve overall sustainability in plastics production. However, most research on bioplastic degradation has focused on downstream environments such as human habitats, rivers, and oceans. This study explores the potential degradation of poly-3-hydroxybutyrate (PHB), a biodegradable plastic, in upstream areas like alpine regions. As the use of biodegradable plastics grows, the concern of bioplastic pollution is expected to extend to alpine regions, including the Antarctic and high-altitude mountains. An intriguing aspect of this research is the potential application of microorganisms isolated from high mountain environments, given their unique characteristics. Therefore, the aim of this study is to isolate microorganisms capable of biodegrading PHB from high mountain environments. In addition, the isolate was further investigated to assess its ability for bioplastic production. The next generation sequencing (NGS) analysis was conducted to compare the bacterial flora from a residential area, campus soil, with that of an alpine region, Metricton, Kurorke soil. Additionally, considering the potential removal of anthropogenic polymer contamination in the alpine area, we aim to analyze the alpine soil, focusing on bacterial flora involved in decomposing fallen wood, a key component of the organic matter cycle. The study objective was to examine potential differences in bacterial flora between the soil and wood debris. For this study, we collected 20 samples, 10 sites from the campus, 14 soil samples, 7 sites from MT Kurorke, along with a significant amount of decaying wood. PHB degrading microorganisms were isolated by clear zone methods using PHB containing agar plates. These microorganisms produced clear zones on the agar plates. The results indicated a greater diversity of bacterial flora in campus soil compared to samples from the alpine region. The wood sample from MT Kurorke showed close similarity to the soil samples from the same region, suggesting the presence of similar microbial communities. Notably, all the samples contained strains from the genera Sphingomonas, Ralstonia, Pseudomonas, Enterobacter, Comamonas, and Streptomyces, a known PHB-degrading bacteria. Among the isolates from the alpine region, strain C16 showed the highest PHB degradation activity and was identified as Ralstonia sp. C1, accession No. LC779623, closely related to Ralstonia insidiosa AU29440, AF488779, with a high sequence identity of 99.7%, 143 to 1436. Notably, strain C1 exhibited the capability to degrade not only PHB but also PBAT, P, 3HBCO3HV, PHBH, and PCl. Strain C1 was able to degrade up to 3% of the PHB polymer. Furthermore, strain C1 could utilize 3HB, a degradation product of PHB, sugar, and fatty acids to produce PHB and P, 3HBCO3HV. In this case, the PHB production using glucose was notably high at 55.5%, PHA production %. Therefore, our insidiosa C1 will be the first report capable of producing and degrading PHB. The PHA extracted from bacterium C1 incubated with glucose was employed to ascertain its structure and physical properties. Fourier transform infrared (FTIR) spectra and 1H and 13C nuclear magnetic resonance (NMR) analysis indicated that the main component of PHA is PHB. In addition, TGA and DSC analyses were conducted and the results showed that the thermal properties of the produced PHA were similar to those of commercially available standard PHB. These findings propose a novel green material circulation model employing biochemical methods crucial for achieving the goals of the green circular economy, including zero emissions. Thank you for watching this video. Please subscribe our channel for watch more scientific research videos.